Good evening, everyone. Tonight we're going to be talking about the area of trapezoids, kites, rhombuses, and regular polygons. So you may recall that a trapezoid has one set of parallel sides called bases, so here labeled base 1 and base 2, and then the height of a trapezoid is the perpendicular distance between the bases, like in a parallelogram. It's not necessarily going to be a side length, it could be in the middle. So then from that we have our area of a trapezoid formula, which is area equals 1/2 base 1 plus base 2 times height. Now let's look at the area of this trapezoid. So here I've got my two bases, 6 and 8, and in this case my height is actually one of my side lengths because you can see here it's the perpendicular distance between the two bases. You can see those two right angles. So I'm going to plug into my formula, area equals 1/2 base 1 plus base 2 times height. So area equals 1/2, 6 plus 8, my two bases, times my height. I'm going to do what's inside the parentheses first, so I have 1/2 times 14 times 4. So then 14 times 4 is 56, so I have 1/2 times 56. So then the area of my trapezoid is 28 feet squared. Now let's look at rhombuses and kites. The important thing to remember about a rhombus and a kite, and also a square, is that they have perpendicular diagonals. So any of these three figures can use the following formula to find the area. So my formula is area equals 1/2 diagonal 1 times diagonal 2. Or we will always simplify that to area equals 1/2 d1 d2. So let's look at my first example. So here I have a kite. So I can see in my kite I have one diagonal of length 6 and then I have a second diagonal of length 14. Even though it's outside of my kite, it shows me that that length from tip to tip of that kite is 14 inches. So I know my formula is area equals 1/2 d1 d2. So I'm going to plug in area equals 1/2, d1 is 6, d2 is 14. So then 1/2 times 84, because that's 6 times 14. So then my area is 42 inches squared. Now let's look at our second example. Here we have a rhombus. Now for this rhombus, they've shown us that a portion of my diagonal is 30 meters, but we know that the entire diagonal is going to be 60 because we know that in the diagonals of a rhombus bisect each other. So then likewise, the horizontal diagonal, this entire diagonal, is going to be 80 because if portion 1/2 of it is 40, then the whole thing has to be 80. So then to find my area, I'm going to start with my formula, area equals 1/2 d1 d2. I'm going to plug in my two diagonals, 60 and 80, so 1/2 60 times 80. So then 1/2 times 4,800. So then the area of my rhombus is 2,400 meters squared. Now let's look at regular polygons. So just as a reminder, a regular polygon is a polygon with all congruent sides and all congruent angles. So in order to find the area formula for a polygon, we really need to look at it while it's inside a circle. So here we've put a hexagon inside a circle. So now point P is the center of my circle. And then the radius of my circle is here. So like PM or PN, both of those have length R. They're both a radius because they go from the center of the circle and the polygon to the edge of the circle. Now here we have a new word, apothem. So the apothem, so that's this here, PQ. The apothem is the distance from the center of the polygon to the center of any side of the polygon. So I could draw my apothem in a lot of different locations. This is the height, or the altitude, of the isosceles triangle that has two radii as legs. So here, this triangle, PMN, it's isosceles because two of the sides are PM and PN. They both have a length of the radius, so that's going to be isosceles. And then PQ is the height of that little isosceles triangle. And then we have the central angle. So that's the angle created in the figure, angle MPN. And we find this, you can find the central angle by using this formula, so 360 divided by the number of sides. So here I have 6 sides, so it's going to be 360 divided by 6, so the central angle in this specific picture is 60 degrees. And then we'll use the apothem to be able to determine the area of the polygon, and so then here our formula is area equals 1/2 little a big P. So a lot of times we'll just say area equals 1/2 AP, where A stands for the apothem, so again the apothem, height of the mini triangle, and then P is the perimeter of the entire shape, so it would be the perimeter of the entire polygon. And then we have one last example that we're going to put in our notes, but we are going to save this for class. So if you would, go ahead and write down the question, draw out the pentagon, and then write down these 4 steps. We're going to fill in everything else in class. And that's everything I have for you this evening. See you in class.